First thing you'll need today is your Chapter 12 tip chart. Some of you have done some lessons already where we defined these two terms, tangent and point of tangency. Some of my classes haven't done that section. So today, you can, whether those are done or not, you can skip on down to Inscribed Angle. That's the lesson today on lesson 12.3 is Inscribed Angles. All right, so what you need to know is, first of all, what one is. An inscribed angle is an angle, of course. And it's an angle whose vertex, or with a vertex, that is on a circle, whose vertex is on a circle, and whose sides, so the sides of the angle, contain chords of the circle. Chords of the circle. So it's an angle whose vertex is on a circle and whose side contain chords of that circle. So I'm going to draw a circle, and I'm going to put an angle in this circle whose vertex is somewhere on the circle. So I'm just going to pick a point. Now remember, a circle has infinitely many points, so you just pick one. So I pick one right there. I'm going to call it point B. And usually C is reserved for the center. And then I'm going to draw chords. So here's a chord for one side of the angle, and here's a chord for another side of the angle. And I'm going to call that point A and point D. Point A, point D. That is an inscribed angle. Now sometimes you'll see it where the points are, where the sides of the angle end at the circle, and sometimes they'll keep drawing those sides that go past the circle like that. And in both cases, that's an inscribed angle. And so I'm gonna write down angle ABD. Now remember, that's not arc, that's this angle. Is an inscribed angle. Now, whenever you draw an angle in a circle, it can be an inscribed one or it can be a central one. So you don't have to draw this up here, but remember from chapter 10, there's a central angle like that where the vertex is the center and the sides are both radii. That's a central angle. Well, anytime you draw an angle, whether it's a central one like this one or an inscribed one like this one, you get something called an intercepted arc. That angle is essentially catching this arc, right? And so that's called the intercepted arc. So that's the next term. Intercepted arc is an arc, of course. An arc that is intercepted by an angle. I'm just going to say that is inside an angle. So remember, an arc is part of a circle. So it's part of that circle that is inside an angle. And that angle can be an inscribed angle or a central angle. Today we're talking about inscribed ones. So you can either just use that same picture and just write that arc AD is the intercepted arc, or you can draw the picture again or a similar picture. So I'm just drawing an inscribed angle. Again, it can end on the circle or you can keep drawing it so it can go past the circle like that. I'm going to put an A here and a D here. Arc AD is an intercepted arc. And it's intercepted by that angle. So if I named that B again, it's intercepted by angle ABD. So this arc that's inside the angle is the intercepted arc. Okay, that's what our lesson is about today, and I'm going to show you some things that happen. Okay, so on the back, I've got some space. I'm going to draw a nice big circle. Nice big circle. Okay, So we learned earlier, you don't have to draw this, I'm just talking, you can just listen. We learned earlier that a central angle let's say this angle is about 70 degrees. We learned that the central angle is the same, has the same measure as the arc. Now, not the same length, that arc length is different, but the measure of it is 70 degrees, just like the angle is. Okay? Well, I'm going to show you that relationship with an inscribed angle. Okay, so I'm going to pick a point out here somewhere. I pick this point right there. It can be any point, and I'm going to draw. Okay, I'm looking at this intercepted arc that is about 70 degrees, right? I'm going to intercept the same arc, but with an inscribed angle. So I'm going to draw this chord right here. Drawing a chord. And I'm going to draw this chord right here. Drawing a chord, right? And I'm going to use some tracing paper. Thankfully, my son is in Miss Baker's class, and they use tracing paper a lot in that class. So at school, I've got something called patty paper that I use. Anywho, I have some tracing paper. Okay, I'm going to trace this, just the inscribed angle, just the inscribed one. So not the central angle, not the circle. This is the inscribed angle. Okay, so I've got this circle that I drew. I've got this central angle that's about 70. I've got this inscribed angle. I'm going to compare this inscribed angle that I traced with this original central angle. Okay, so I'm going to put this point on the point of the central angle, and then look what happens, y'all. Okay, so I'm comparing this purple one that I traced to this central one, and hopefully you can tell by looking at that that inscribed angle is half of that central angle, right? And that would happen every time, no matter what size the circle was, no matter where I drew the inscribed angle or the central angle, that's going to happen every time. So the moral of the story is this inscribed angle right here is half of that central one, which means it's half of the arc. So this is a 35-degree angle. So that is the theorem for today. Now there's more that happens here, so I want to come back to that. But on the notes paper, in this box, it says the measure of an inscribed angle is half the measure of its intercepted arc, and thus half the measure of the central angle that intercepts that arc, okay? So, so this angle, this inscribed angle, is half of this arc. Now in this picture, the central angle isn't drawn, but if I drew that central angle, which you do not necessarily have to do because it makes the picture a little uglier, that angle and that angle, when you compare them, the inscribed angle is half of that one, and also half of the arc. Okay, so let's do a couple problems with that, and then I'm going to talk more about this picture in just a second. Okay, so the rule is that the inscribed angle is half of the intercepted arc. So angle is half the arc. Now I'm writing it that way because of a lesson that's coming after this, and so that's gonna help us make connections with another lesson that we're gonna do. So I'm just writing the rule. The angle is, inscribed angle is half the measure of the arc, okay? So the angle, x, means equals half the arc. So see, it became an equation that we can solve. The angle is half the arc, so x is half of 84, which is 42. So that angle is half of that arc, half of 84 is 42. Now, be careful, because sometimes they give it to you backwards. So everybody look at example 2. This is the inscribed angle, this is the arc. The rule is that the angle is half the arc. Now that's when we're talking inscribed angles, not central angles. Remember, central angles are the same as the arc. But when we're talking inscribed angles, this is the rule. So the angle this time was given to me, 20, is half The arc is what's missing. So 20 is half of what number? That would have to be 40. Another way of looking at that is to solve this, to get rid of the half, you would double it, you would multiply by 2. So you get 40 equals x. Okay, so just to sum that up, if they give you the arc, you half it. If they give you the angle, remember the angle is halved already. So you double it to get the arc. So these problems are backwards. Converses. All right, let's do one more. And then I'll show you some more things with that drawing that I just did. Okay, they want the measure of arc ABD. That's supposed to be a little curvier. It's just the symbol I had to choose from was not very curvy. Okay, so they want the measure of arc ABD. Let's find that. So ABD means it's major because it's 3 letters. So it's this arc, ABD. All right, the rule we just learned says the angle is half of that arc. So this angle right here, this inscribed angle, is half of this arc, which makes the arc 82. So the angle is half the arc. The angle 41 is half of this unknown arc up here. I'm going to call it x. And so if you double both sides, you get 82. So that's what this is. I'm going to erase the x here. This is 82. Angle is half. All right, but they don't want that arc. They want this major one. And they want the measure of it, not the length of it. It's a good thing because we can't find the length of it because we don't have a radius. Anyway, they want this measure. So if the whole circle is 360 and you take out 82, you get 8 and you get 7, 278. 280, 360, yep. So here's how you write that. The measure of arc ABD is 278. That's the major one. The minor one is 82. Okay, so that's using that rule. Now let's go back to this picture for a minute. So we talked about that this inscribed angle is half of this arc, or another way of saying it is half of this angle. Well, if you draw the inscribed angle anywhere in the picture, now just to make it a little easier to see, I'm going to erase the central one just to clean it up a little bit. Just erasing the central one. Okay, if I put an inscribed angle anywhere that intercepts that same blue arc. Okay, so I'm going to put an inscribed angle here that intercepts that same blue arc. Boom. Boom. And then I'm going to put another one that intercepts the same arc. Boom. And boom. I wish I had this stuff for you guys to do this with. Let me do one more. This is getting kind of crazy looking, right? There's a red one. Same blue arc. Boom, and boom. Now this picture is starting to look crazy, right? All sorts of crazy things everywhere. Okay, remember that I originally traced this one, right? So that's, yeah, that's the one in pencil. So that was the original one that I traced. Okay, I'm gonna compare this one that I traced to all the ones that I just drew. Okay, so the first one I drew was this blue one. Look, same exact size. The next one I drew was this darker blue one. Same size. The next one that I traced is this red one. Same size, right? But I only traced the original one. All right, so let's talk about why that happened. If the light blue one is intercepting the same arc, it is also half of that arc, so it's 35. And if the dark blue one is intercepting that same arc, then the dark blue angle is half of that arc, which is 35. And if the red one is intercepting that same arc, then the red angle is half of 70, which is 35. If they're all 35, they're all the same size, which means when I compare their sizes with this tracing paper, they're all the same angle. Okay, so I mentioned that to show you that these pictures can get kind of crazy looking, and they look way harder than they are. So if you see a problem that looks like this, let's say there's an angle here and another angle here, like that, okay? Let's say I give you this arc is 80 and this arc is 100. That would be this one, right? That's 80. And this one, that's 100. Okay, we can find all the angles in these triangles. That one's not too straight, it's bugging me. Anyway, so here's what you need to look for. You need to look for like pizza slice shapes, or maybe like ice cream cones where the ice cream part has kind of been, you know, flattened down, like you've been eating that for a while. And so look for this kind of shape. And so here's what I mean. So see that? That's our flattened down ice cream. That's the cone part, right? That's an inscribed angle forming that, or intercepting that arc. So this is 40. But then it happens again right here. So see, this is another, see that same ice cream. This is another cone intercepting that same arc. So it must be 40. And then we can go backwards from that, right? We can use the 100 instead. So looking at the 100, so thinking of the 100 as kind of that flattened ice cream or the crust of the pizza, however you want to think of that. Just most people don't cut their pizza all the way across to the other side. But anyway, so that's the arc part, and the angle that intercepts it, the inscribed angle that intercepts it, is half, so this must be 50. And then there's another one intercepting the same red arc. So here's the inscribed angle, same arc, so this must be 50. And then we can get these because of the triangles. So since those had to be 90, if you subtract 90 from 180, this must be 90, and then it happens again right here. So see, we can find these missing angles in this picture. So these pictures, they look way more complicated than they are. So what you need to be looking for is shapes like this. So, you know, if this is 102, then this is 51. If this is 60, that angle there, then this must be 120. So that's what you look for. You look for these like ice cream cone kind of shapes with kind of flattened ice cream. Okay, so back to this. So see, this picture looks really complicated. But if you look at angle 1 and angle 2, which they're naming here for us, this angle right here is 2x plus 4. That should really have a degree mark. And this is x plus 34 degrees, because those are angles. Well, those two angles are intercepting this same arc. Angle 1 is intercepting this arc, and angle 2 is intercepting the same arc, which means both of those angles must be half of the arc, which means they're equal. So those angles are equal. So the way you do this problem is you go 2x plus 4 must equal x plus 34 because they're intercepting the same arc. And then you guys could solve this all day long, no probs. X plus 4 equals 34. X is 30. So if x is 30, that means, not that they asked for x, so you're really done. But now we could find the angles. The angles are 64 because 30 plus 34 is 64. So, and then if you plugged it into angle 2, I did plug it into angle 2, sorry. Angle 1, 2 times 30 is 60 plus 4. These are both 64. And then you could find this arc too, because if the angle is 64 and the angle's half the arc must be 128. So they could ask you some other questions about the picture is what I'm saying. Okay, so x is 30. one more cool thing happens with, actually a couple things. But, so let me go back to what we were doing over here. Okay, so I just told you that the inscribed angle is half of the intercepted arc. So let me draw you a nice big circle again. Okay, so there's the center, right? If we draw a diameter right here, we've now got ourselves a semicircle, right? And if we put an inscribed angle, if we put an inscribed angle in there, so that the intercepted arc is this semicircle right here. Okay, so let me show you what I mean. I'm gonna put an inscribed angle, and that's gonna be my arc. So I'm gonna put a point right here. Okay, let me connect these guys. Okay, so here's an inscribed angle, right? That's the arc that it's intercepting. So imagine that's kind of like our big ice cream cone looking thing, right? Well, we learned a few minutes ago that the angle is half of the arc. Well, if the arc is a semicircle, which is 180, what kind of angle would that have to be? If it's half of the semicircle, it would have to be 90. And now, I did not measure anything, right? I mean, I drew a circle with a circle maker, and I made sure it was a diameter, so I went through the center. You know, so I knew for sure that had to be 180 because that's a diameter. And then I drew an angle, and look, it really is, I'm just using the corner of a piece of paper, it really is exactly 90. So that angle is half of the semicircle. And you could put one anywhere. So you could inscribe an angle right here. As long as it's intercepting that semicircle, it's gotta be a 90, see? 90 degrees exact, like without measuring anything. I think that's so cool. So you could put an angle right here, right? And it's gotta be 90 because it's intercepting that semicircle. Okay, that picture looks so neat. All of you in the room who like to do perspective drawings, I mean, don't you just want to do something with that? Anyway, so it's a corollary to the original theorem. It says if an angle is inscribed in a semicircle, remember that is a 180 degree arc, then it's a right angle. It's half of 180. All right, so this picture here, I know that this is a diameter because it's passing through the center. That's why they'll put a C there in a circle to let you know that that's a diameter. And so that means this angle right here, this angle, is an inscribed angle. I'm going to trace it. Inscribed angle, intercepting that semicircle. So this angle right here, without marking it, they're not going to mark it for you. You know that it's 90 because it's half of the semicircle. And then we know the angles of a triangle had to be 180. We've known that for a while now. So you take 180 and you take out the 90 and the 42. 90 plus 42 is 132. So you take out 132 and that leaves you with 48. That's what X is. So X is 48 degrees. Okay, one more thing to talk about. All right, so there's another rule that happens with all this, that if you inscribe a quadrilateral into a circle like this, so it has to be inscribed in the circle, meaning all four vertices are on the circle like this. Okay, look what happens. This angle X is intercepting this arc. And this angle 3x is intercepting this arc. So this X is intercepting this red arc, and this 3x is intercepting that blue arc. Well, together, doesn't that make up the whole 360 degrees? Which means together, those angles are half of 360 degrees. Now that's together. So that means those two opposite angles must be supplementary. So you get 4x equals 180, and then you divide by 4. X is 180 divided by 4. 180 divided by 4. 45 degrees. So x is 45. This angle is 3 times 45. All right, so the rule about that is if a quadrilateral is inscribed in a circle, if a quadrilateral is inscribed in a circle, the opposite angles are supplementary. In other words, they add to be, sorry about my sloppy writing, y'all. They add to be 180 because they're going to intercept together, they're going to intercept the entire circle. So even if we were talking about these guys, this one and this one, this angle intercepts this arc, right? And this angle intercepts this arc. So see, it makes the whole circle. So even if we were talking about these opposite angles, they're going to have to be supplementary because they intercept the whole circle. All right, that is all there is to inscribed angles. All right, y'all have a great day. Bye.